Not always, I guess. Okay, limit as x approaches plus or minus infinity. Works the same either way, whether it's positive infinity, negative infinity, the rules really do not change. All right, the limit as x approaches infinity of 1 over x. That big space there was not intentional, but we can deal with it. The limit as x approaches infinity of the function 1 over x. All right. We're going to talk about it a few different ways. We're going to talk about looking at the function, plugging infinity in, graphically, so that we can have a good understanding of what this means. First, let's plug it in. 1 divided by infinity. Any guesses on what that's really close to? All real numbers? What is it?
Can't be 0.
Can't be 0? Think of 1 as an item, like a dollar. Think of this as $1, and you divide it amongst an infinite amount of people. How much does each person get? Like nothing is correct. Because even dividing it among 100 people, you only get what? 1 cent each. So if you divide it amongst an infinite amount of people, you'd end up with nothing. Right. 0.00000001. So all right, so very close to 0. Do you agree? All right, so let's talk about this graphically. At this point, we still don't have the tools to graph. We will learn those tools tomorrow. But this is what the graph of 1 over x looks like. And I think you do have these tools, actually. I haven't shown them to you, but you did do them last year in Math 3. Okay, approaching infinity. Off to positive infinity. Do you agree that this is positive infinity? Yes? And as I go off towards positive infinity, what happens to this graph? It gets closer and closer to what y value?
0.
Does it ever touch? No. But does it get closer and closer to 0? Yes. 0. Make sense? All right. Number 2. The limit as x approaches infinity of 100 over x squared. No graph on this one, just 100 over x squared. All right, so think of it as $100 now instead of 1, and you're dividing it amongst infinity squared. Infinity squared is still what? Infinity. So $100 divide amongst an infinite amount of people still ends up being what? 0. It still ends up being close to 0, so we say 0. So what can we say about any number divided by infinity? So any number divided by infinity equals 0. Does that make sense? When you're taking the limit, as x approaches infinity and you plug infinity into the denominator and you have a number at the top, a number divided by infinity is infinity. I'm sorry, 0. All right, number 3, we're going to change it up a little bit. The limit as x approaches infinity of 2x plus 5 over 6 minus x. Is this a little different than the last one? Last 2. Do you agree?
Yeah.
Yeah, when I plug in infinity, 2 times infinity, so I have infinity plus 5 and 6 minus infinity, not as easy as these 2 up here. So there is a method, a process we're going to go through. Are you ready? Yes? Okay, we're going to divide everything by the highest power of x. Divide everything by the highest power of x, then take the limit. All right, and so by the highest power of x, I mean the largest, the degree, but looking at the top and the bottom. Okay, so what's the degree of the numerator? What's the degree of the denominator? 1. So we're going to divide everything by what? 2x divided by plus 5 divided by 6 divided by minus x divided by. What are we going to divide everything by? X squared or x? Just x. Do you agree that x is the largest exponent because these two both have a power of what? Yes? Okay, so before you take the limit, of course, we're going to simplify. On the first fraction, what reduces? The x, and I'm left with 2 plus 5 over x. Next one, 6 over x does not reduce. Minus, what does this reduce? Minus 1. All right, and now we're going to take the...
Why would it not be 7 over x? 7 over 2x.
Like, why wouldn't we add these together? Is that what you're asking? I'm not sure what you're asking,
Yeah,
Austin.
the 2x plus the 5x, doesn't that give you 7 over 2x?
This is not 2x, it's just 2. 2 plus 5 over x is nothing because they're not common denominators. And yeah, and if I did find a common denominator, I'd work backwards and back this way. All right, so I don't want to add these together, but I am going to take the limit. And what did we just say in the last two problems? Any number divided by infinity is what? 0. So 5 over infinity is going to become what? 0. So I'm going to have 2 plus 0. And then 6 over infinity is going to become 0 minus 1. I end up with 2 over what? Which reduces to negative 2. All right, digest, ask questions before I move on. Not that hard, or it is hard? Not that hard. Interesting. We are eventually going to learn a shortcut on top of all of this. All right, the limit. I shouldn't tell you then. We'll save the shortcut for tomorrow then. Oh. All right, x over x squared plus 5. The limit as x approaches negative infinity of x over x squared plus 5. All right. What did I say earlier about plus or minus infinity? Does it matter? No, they work the same way. Okay. What's the largest degree here, top and bottom? 2. So I'm going to divide everything by what? Everything by x squared. Even if this x squared had a coefficient, you still just divide by the x squared. So you can divide by x or x squared or x cubed, depending on the problem. Okay, first one reduces to what? X or 1 over x? 1 over x. This one down here reduces to 1 plus 5 over x squared stays. All right, then you take your limit. Does it matter whether it's positive or negative? And remember, any number divided by plus or minus infinity is 0. What do we end up with? Is it 0? What's 1 divided by infinity? 0 over 1 plus 5 over infinity? 0. So 0 over 1 is still 0. Questions? Yes? Can anyone answer that question for him? His question was why x here and this one x squared? Everything, she said you divide everything by the highest power of x. Degree of 1, degree of 2, so 2 is the highest power. Does that make sense? Go ahead and ask.
And why is it negative, or was it negative?
Nothing. The negative infinity is the same as positive infinity. You treat them the same way. It doesn't change the way you solve the problem at all. For sure. If you look over here at the graph, do you agree as I go to negative infinity, my line is still approaching the y value of 0? Whether I'm going to positive infinity or negative infinity, is it still approaching the y value of 0? Yes. All right, questions on number 4 and how it came out to be 0. All right, number 5. The limit as x approaches negative infinity of 5x squared minus 4 over 2x squared plus x plus 5. I'm going to let you guys try this one on your own. What are you going to divide everything by? X squared, not 5x squared, not 2x squared, just x squared. All right, I reduced mine. Can you guys double check yours? Did you reduce yours to this same piece here? And then you take the limit and tell me what you guys ended up with. 5 minus 0 over 2 plus 0, which is 5/2. Yes or no? Did you guys all end up with that? Okay, questions on that one? Okay. The limit as x approaches infinity of 3x squared over 3x. All right. What are you going to divide everything by? X squared. So go ahead and do that now. All right, what did you guys get? D and E. Why? Because you end up with 3 over 0 D and E. What does D and E stand for? Does not exist. If you put undefined, D and E, 0 with a line through it, I would accept any one of those. All right, any questions so far? Are you guys ready for the shortcut? Or you don't feel we need one? Don't need one? Show it and then you guys decide. Okay. 3 scenarios we're going to end up with. Bottom heavy, top heavy, or same degree. Okay, first shortcut. What happens when it is top heavy? I do suggest you guys at least listen here because it will help you in the long run when we're graphing to know what I'm talking about when I'm talking about top heavy, bottom heavy, or the same, because I will refer to this. All right, top heavy means that the degree at the top and the bottom, the degree at the top is larger than the degree at the bottom. Degree at the top is larger. And we know the top means the numerator. The degree in the numerator is larger. All right, so let's look through our notes and see if we have any, and I don't know. Oh, number 6. Is 6 the only one that ended up that way? Okay, so look, this one, would you say the degree at the bottom's bigger? Degree at the bottom's bigger. This one is not bigger, it is the same. This one would be considered bottom heavy. This one would be considered the same. This is the only one we had that was top heavy. And what did the answer come out to be? D&E. That will always work out that way. Always. I know we only did one in our homework, but it will always work that way. All right, so the limit as x approaches plus or minus infinity is always going to be D&E when it is top heavy. Okay, next one, number 2 is bottom heavy, which technically should have been my number 1, but we can put it as number 2. It does not matter. Bottom heavy means what about the degree? Okay, the degree at the bottom, the denominator is larger. All right, how many bottom heavies do we have? Is number 1 a bottom heavy? Is number 2 a bottom heavy? Is number 3? What about 4? 4, and is there any others, or is just those 3? Just those 3, and all 3 came out to be what? 0. Is that always going to happen when it's bottom heavy? Yes, because that's going to mean infinity at the bottom, and what's any number divided by infinity? 0. So the limit...
Is the limit always going to be infinity?
This shortcut here is only for when the limit is approaching infinity. You don't use the shortcuts because if it's approaching 5 or -3 or 2, what do you do with that number? Plug it in. It's only when infinity that you use the shortcut. Does that answer your question?
Is there a shortcut for the other?
No, those other ones weren't that bad though. You just plug them in. They were pretty easy. All right, number 3 is what? Same degree, top and bottom. I don't have to explain that one because it's in the title. Same degree, top and bottom. All right, so how many of them did we have that were the same degree, top and bottom? Was number 3 same degree, top and bottom? And number 5? And what did number 3 come out to be? And what did number 5 come out to be? 5 halves? All right, so let's take a look and see. -2. What you do, let me write it down and then we'll talk about it. What you're going to do when the limit as x approaches plus or minus infinity, when the same degree is top and bottom, you will take the leading coefficients. Of top and bottom. All right, so it's not as quick as just D&E or 0. It is still quick. It actually takes longer to write than it does to figure what it is. You take the leading coefficients of the top and bottom. All right, does everybody have that down so I can move it or not yet? So I'm going to take a look at number 3. Can you guys take a look at number 3? What's your leading coefficient in the numerator? 2. Do you guys see that? I'm going to move it. I'll put it back in just a little bit. Okay, leading coefficient here is 2. What's the leading coefficient in the denominator? 6 or -1? -1. And what's 2 divided by -1? Oh, did it work? All right, let's take a look at this one. Do you have an assignment sheet already? Okay. The next one here, what's the leading coefficient in the top? What's the leading coefficient at the bottom? and 5 over 2. Did it work? Oh.
Wait, say that again?
Okay. Leading coefficient, what's the leading coefficient here? 5. What's the leading coefficient here?
2.
And 5 over 2 is 5/2. Is your leading coefficient always going to be the first variable on the top and the bottom? No, like this one over here, 6 is not the leading coefficient. The leading coefficient's -1. Do you see that? Yes or no? All right. Let's just try a few, and we're going to see if we can use the shortcuts. All right. I'm going to move this. If you don't have this down, you can get it from a neighbor, but I'm going to move it really quick. So trying some with the shortcuts. Number 7. Oh, that's an ugly infinity. Sorry. Okay. So when you have these, instead of doing all the steps that we've done, you look, is it top heavy, bottom heavy, or the same? And when it's the same, look at your notes for now. If you don't remember, what do we do when it's the same? The leading coefficients of the top and the bottom. What's the leading coefficient of the top? 2. So it's 2 over, what's the leading coefficient of the bottom? -8, not 5. So 2 over -8 reduces to negative. All right. Like the shortcut? Okay, number 8, the limit as x approaches infinity, bless you, of x plus 7 over x squared. Top heavy, bottom heavy are the same. Bottom heavy, look at your notes if you don't remember. I think of bottom heavy as anything over infinity. What does it equal? 0. All right, next one. Yes?
Say we did it the shortcut way on the test. Do we have to show any work?
Nope. No, good question. She asked if we do it the shortcut way on the test, do we have to show any work? No. X cubed plus 7x squared plus x minus 5 over 2x squared plus 1. Top heavy, bottom heavy are the same. Top, look at your notes, unless you have it memorized. Top heavy is what? Danny. What was that? Right. See, things like this would take a little bit longer. He's saying, imagine if we didn't know this shortcut. I do have one more to show you. That's one that you're going to see in homework tonight. The limit. So he was saying it would take a lot longer. So use the shortcut. Know it. The limit as x approaches infinity, brackets, 6 plus 3x squared like this.
The whole thing.
What was that?
Chris is already complaining you said the whole thing.
All right, it looks like that. All right. He's saying common denominator first. You can, or you can do it piece by piece on this particular one. Are you guys okay if we do it piece by piece? Yes? All right, so the limit as x approaches infinity of 6 plus the limit as x approaches infinity of 3x squared over x. I'm gonna FOIL that one out just so we can see our coefficients. Can you guys FOIL that out in your head? X squared plus what? Plus 8x plus. All right. First one. The limit as x approaches infinity of 6. Any thoughts? Because there's no variable, it's not going to change. It's always going to be what? So even if I go off to infinity or negative infinity, it's going to stay constant because 6 is a constant. So it's always going to remain what? 6. Does that make sense? Plus, what do we have here? Top heavy, bottom heavy are the same. Same, and when it's the same, we take what? Leading coefficients. What's the leading coefficient at the top? What's the leading coefficient at the bottom? And 3 over 1 is just, and 6 plus 3 is 9. Make sense? All right.
How many